Bar plots. Bar plots helps to compare different items. They are often used when comparing the categories of data. So let's build a data frame and then we will be building a bar plot on that data frame. For that I am creating three vectors first. First is for cars, then trucks, then SUVs, and we will be merging it to a data frame. And next I am creating a variable autos data with formula data frame and giving the names of all the vectors. So if you want to check the data of autos data, you can see this is the data frame that we created. Now we are creating a bar plot on it. For creating a bar plot, the formula is bar plot. Within the brackets, we will give the different aesthetics. The first is the data set or the column that you are using. So I'm building a bar plot for a single category of autos data, that is cars. I'm giving the title to my graph as auto data, then X lab, that is the X axis label, then the Y label, then name of arguments. So these are the different names that will be given to each of the columns that will be created, each of the bars. Then next is the border. So the border of each bar will be blue, and density. So density is the within the bars, what will be the shade that will be given. So first I'm removing this density and you can see what the bar plot first. So you can see this the x-axis having Monday, Tuesday, Wednesday, Thursday, Friday, and all the numbers have been the totals around y-axis, and the density right now is filled with light gray color, border is blue. Now if I give density, I'm giving a aesthetic density here with like I have 5 bars, so I'm giving 5 numbers here with 10 density, 20, 30, 40, and so 50. That's executed. So you can see the number wise the density is changing. So first when I have given 10, it is the light density inside the bar, and similarly the last one is with high density shade. Now I'm creating a data bar plot with adjacent bars using rainbow colors. Now I'm using whole data set right now, and it will be a multiple bars adjacent to each other. For that I'm converting the autos data, that is a data frame, to a matrix and giving the title of the data of the graph as autos, y label as total, and beside is equal to true. So what does it make? Give the differences, like right now each bar is different from the other. When I do besides, the change will be, you can see for cars the bars are adjacent to each other, like the number was 13649, so it is grouped together and with each other beside each other. Similarly for trucks and SUVs, the colors have been taken as rainbow color with 5 colors of rainbows. So you can see each of the bar is of different color of the rainbow. Then we will give the legends to this graph. We will be giving the position as top left. So top left will be here. You can give any other position you want. It can be bottom left, bottom right, top right, or the only top, which will be given on the middle of the graph, center of the graph. Then the name of the legends, that is Monday, Tuesday, Wednesday, Friday. CXC is 1. So the size of the legends will be default 1. BTY is the type, that is the BTY is the type of box in which the colors will be filled in, and I'm taking rainbow as fill. As you can see, we have taken rainbow for plotting the bar plot. So let's execute it, and you can see a legend here wherein different days has been mentioned and rainbow colors has been filled in it. Next, we will be building a bar plot wherein we will be transposing the data, and different shades of the color will be filled in. So next I'll be using heat colors, and 10% of the space between each bars and make labels smaller with horizontal y-axis. So now the data will be transposed, therefore the axis will be y and x will be transposed. So you can see inside the bracket I have transposed the data frame. I have given the title as autos, ylab is total, colors I am taking heat colors, and the number is 3. So I am taking 3 heat colors right now. Space, what does space do? Space will give the gap between each bars. Says CXC axis, it is the axis size of the axis label. It will be 0.8. Default is 1. I'm reducing the size to 0.8. So next is LAS. So what does LAS do? As you can see in the current graph, in the y-axis, the numbers is in slant. 0, 5, 10, 15 are in slant. If I do make it 1, it will be in the right direction, upright direction, top bottom direction. You can see the change once I execute this command. Name argument. So the x-axis will be named as Monday, Tuesday, Wednesday, Thursday, Friday, and the size of that of the point graphs will be 0.8. Let's execute it. So you can see the data has been transposed. So how do you know the data is transposed and how is it created? So my data that I created was autos data. This was the original data that I created. If I transpose it, the command for transposing is T. So the columns and rows has been reversed. There are now 3 rows and 5 columns. Similarly, the graph has been changed because earlier there were 5 columns. If you want to check that, see there were 5 bars here for 5 columns. If I transpose this data and plot the graph, the bars are stacked and there are only 3 stacks there because the data is transposed into trucks, cars and SUVs. That means 3 rows. And the title I have given is autos. Now you can see Monday, Tuesday, and the days are in small font. If you want to increase the font size, you can increase the cxc.axis value. I have taken 0.8 earlier. Let's take 1.5 here. And the last, you can see the change with LAS equal to 1, the y-axis numbers, the direction of them has been changed. If you want to see the change, I'll make it to 0 and check the values. Here also 1.5. So you can see the y-axis numbers has been changed to, has been increased to 1.5. Similarly for x-axis. And the last, if I, what I did was LAS equal to 0, then the direction of y-axis numbers have been changed. So I'm again doing it to 1 and reducing the font size because it looks messy with large with alphabets. So let's make it 0.8 again, or you can take 1 as a default. Now let's add legend to this. I'm adding legend to top left, giving 3 names that are the rows, the cars, trucks, and SUVs. Then the CXC size, the size of these fonts. Then the square boxes for the box type, and filling the colors with heat colors that I have used for bars. You can see if you want to change the direction of this legend, what we can do is we'll just do a top here and remove left. You can see the position has been changed to top, that is the middle on the top row. Or you can do like it will be best where the graph is empty to create a legend there. My right side has been filled with the bar, so I'm not taking legend on that side. It's better to take on top left. It is more tidy and better to present. So the bar plot is easy to create. It helps us to compare different items. Like you can see, the red color here in this graph is for cars, orange is for trucks, and yellow is for SUVs. On Friday, the number of SUVs used are highest, and on Wednesday, You can see the number of cars used is around 8. So it helps to compare the data. If you create a general data, like we have created this, so you can see on Fridays the number of used cars is the highest. That automobiles used on Friday are the highest count.